talked about multiplying powers with the same base. And if you're multiplying powers, you're putting them together, that means you're adding them or multiplying the exponents to get the answer. Okay? Today, we're going to talk about dividing powers. And so, this is having the same number with an exponent over another number, the same number with an exponent. And when you do that, the principle is, like, a over a is 1, right? Well, remember when we simplified fractions before?
Mm-hmm.
So a to the 4th over a to the 6th is just
Oh,
a's, and then the leftovers go on the answer. Okay? Or, look at this now. This is how you apply this to exponents. Since we are subtracting, we have a to the 4th minus 6. What's 4 minus 6, Pete?
2.
No.
Oh, yeah, -2.
Negative 2. So if it says a to the negative 2, what does the negative power mean? How can you write that without a negative? Look at what's equal here. They're so circled. The ones that are circled are equal. So an a to the negative 2 means, read this, somebody?
Oh,
Bennett?
1 over a2.
Yeah. So the negative, when the negative is on the top line, it's positive when it's in the denominator. Okay? It means the positive in the denominator. Okay? It's like the reciprocal of a squared. Okay? Now, remember back when I taught you the rule about any number to the 0 power equals 1? Do you remember that?
Yeah. Yes.
Any number to the 0 power is 1, right? Hello? I'm standing in front of you because I want you to look at me. And I want you to see this. This is why. This is why that rule applies. Because if you have the same number of numbers on the top line as the bottom line, they all cancel out and it equals 1. Okay? Or, what's a to the 3rd minus 3? A to the 0, which is 1. That's why any number to the 0 power is 1. Okay?
Wait, what do you mean by an example A 4 minus 6?
A to the 4, see, since we're subtracting the exponents, here's the 4 and here's the 6. So it's a to the 4, this 4, minus 6. And that equals 1 over a squared. It also equals a to the negative 2nd power. Okay? Hey. Alright. Let's do some together. Let's see how much you understand.
Wait,
Come back.
Whoa,
Yeah, I know. Calm down. Get your notes later. Alright, look at the worksheet. Let's see what you get. Okay? How would we show the step to get this using subtraction? 7 to the 8. And then, since they're being divided, do we add or subtract the exponents? Subtract. So it's 7 to the 8 minus 2, which is 7 to the 6th power. And that's how I want you to write these.
That's it?
Yep. Number 2.
So it's kind of like
x
subtracting.
to the, raise your hand. Kind of like subtracting, it is subtracting. Subtract the exponent.
No, but like the instead of dividing like fractions plus we subtract.
You subtract the exponents, yeah. X to the 5th, what would we minus in this one?
1.
Good. X to the 5th minus 1. This would be x to the 4th. How about 5 to the 0?
Equals 1, right?
Yeah, that just equals 1. How about n to the negative 3rd? Remember what a to the negative 2nd? So what we do is we write this as the denominator (1 over n to the negative 3 or positive 3? The positive 3, yep. N to the positive 3.
Why positive?
N to the negative 3 is equal to 1 over n to the positive 3. I'll give you an example. Let's say that it was n over n to the 4th. Well, that would be n to the 1st minus 4,
Which equals 1 plus
which
negative
is
4.
n over negative 3, or that would equal n over n times n times n times n,
You're making this.
which is 1 over n to the 3rd. These would cross out and we'd have 3 left. So that's why these two are equal.
How? Exactly.
Look at the example again
What is it?
that I just wrote down.
Yeah, but you said 4.
Yep.
That's not 4, it's 3.
No, this is an example of how you get to negative 3. n over n to the 4th gives you n to the negative 3, doesn't it?
Sure.
Just nod your head.
I don't know.
Then-
You didn't show it.
Yes, I did. N to the 1st minus 4. Okay. Liv, stop talking.
It would be a positive. You have to change it to negative.
Yeah, yep. Oh, you mean in number 5? No, then we would leave this as y to the 4th on the top line over x to the 2nd on the bottom line.
Oh.
See, when you move it from one side of the line to the other, it makes it the opposite. It makes it either positive or negative.
What?
It makes the exponent positive. It changes the exponent from negative to positive if you move it to the other side of the fraction bar. So if you move it from the top level to the bottom level, it becomes the opposite, because it's on the opposite side of the line.
I'm so confused.
In other words, like n to the negative 3rd, if we move the n to the power to the bottom, or to the numerator, then it's positive.
He was never.
Stop talking. Yes?
How do you know when we're on the top and the bottom?
If it's negative, it goes to the bottom. So the x to the negative 2 is negative, has a negative exponent. We would move that to the denominator. If it has a negative exponent, then you move it to the opposite side of the line.
Then how would you do like number 14 then?
Whoa, you're way ahead of me. Okay, how about start with number 6. Like 6 has a positive exponent, so that stays on in the numerator. A to the negative 3 has a negative exponent, so that goes to the denominator and becomes positive. Raiden?
How do you even know it was at the top? It doesn't say.
Yes, it does. It's right next to the 6.
But I'm talking for number 5.
Number 5,
Who has a possible?
it's right next to the y.
But it was never a fraction in the first place.
Oh, so what? Yeah, sure. So let's say that you
So what
write
if
the
it was
number.
already at
Okay,
the
well,
bottom?
I'm going to answer your question now. So hold on. If you write the number 5, is that also 5 over 1?
What?
If you have the number 5, is that equal to 5 over 1? Yeah, it's just this number written as a fraction, right?
Yeah.
So when it's just written, it's always assumed that it is on the top of the fraction bar. Because you can write that as a fraction just by writing it over 1. Anytime it's just written without a fraction bar, it's always on the top. It's automatically on the top line.
Okay.
Okay?
But then why would you? It wouldn't be equal then if you put the other number to the bottom.
Yeah, it would. That's what I'm trying to tell you. Because if you have a negative exponent, what it means is that it may have been created by having less of the exponent, less of the number on top than on the bottom. Like, remember when the first example I gave you? X to the 4 over x to the 6. That creates a negative exponent if it's all written on the top line. Because x to the 4 minus 6 is x to the 2, negative 2. Okay?
That makes no sense to me.
Okay. When we write this out, if we wrote this out in expanded form, we would have y times y times y times y over x. Let's say that we had some x's up here.
Why is the x up there? But see, that makes no sense.
Well,
why would you change it if it was on the top originally? Why would you change it down when all you want to do is bring it back up again?
sometimes you have to move it.
Why is when it was already there?
Sometimes you have to move it from the top line to the bottom line. Sometimes you have to move it from the bottom line to the top line. Okay?
What you're making, when you're trying to write it out, you're moving it to the bottom line when you really want it on the top line. Why would you move it then?
To make it positive. To show what's equal.
But it's not.
Yes, that's what I'm trying to show you, is that it is equal. And here's why. Here's an example why. Okay? So, if we had x's on the top and the bottom, these would cancel out. The two of them on the top would cancel out two of them on the bottom. And two of them would be left.
Where are you? Oh my gosh.
Okay?
That makes no sense.
You know how to cancel out the numbers.
Yeah, but how did you get the numbers on the top?
I'm showing you how this situation could be created. Because what it's just giving you is the answer. This is the answer to a question with a negative exponent. And this could be created by this situation. Okay? It's kind of like when you're doing math, sometimes they just give you the problem, and sometimes they put the problem in a word problem, in a real world situation that creates that problem. What I'm trying to do is show you an example of a situation that would create this answer.
Okay, but how does that have to do anything with the fraction that we're talking about?
Because that way I can show you how these are equal. I can show you that y to the fourth over x squared is equal to...
See, but it's not y to the fourth to the x squared. 2x squared. So where are you putting the extra 5? 6 x's. Where are you getting the extra 6?
What extra 6?
The 4 on the bottom and then the 2 on the top.
Yep.
Where are you getting them then?
Like in a real world problem.
But
Okay?
it doesn't say in the problem.
No, not in this one. No. You asked me how would we get this?
I'm saying how would you get 4 to the 4th to the x to the second when
So Raiden, to simplify this, the rule is that if they have a negative exponent, if you move it below the fraction bar, it becomes positive. That's all you have to remember.
Yeah,
Okay?
but then when you try to explain it to me, you made no sense because you added 6 more x's.
Because you said why. And so then to answer the question why, I'm showing you how that could be created. Okay? You don't have to know that. You could just memorize the rule that says if the x has a negative exponent, if the number has a negative exponent, then you can just move it to the denominator to make it positive. Okay? If you want to know why, then I can create a real situation that shows you why. But that seemed confusing to you. So maybe just remembering a negative exponent, when you move it to the denominator, becomes positive. Okay? Take. Just like a to the negative third, when you move it to the bottom or to the denominator, becomes positive.
Okay, but how are they equal? I just did it on my calculator, and they're not equal.
They are equal. Yes, they are equal. You could just
X?
again, I can show you why, but I don't want to confuse you like I did before.
If you're putting a number to it, like if we're saying 4 to the negative, if we're doing 4 to the negative second power, okay, so we're doing 4 to the negative second power, and it equals 0.0625. We do 4 to the power of 2. It equals 16. How is that equal? See, that's what I'm saying. It doesn't equal each other.
Yes, it does. It does. The best example might be powers of 10. Okay? When you have a power of 10, it creates either 1 or 10 or 100 or 1,000.
You have the negative
right?
power.
And the negative power is 1, if you put in your calculator, 1 times 10 to the negative second power, for example. 1 times 10 to the negative second power. That's 100. It's 1 over 100. So moving that 10, that 100 to the denominator. That's an example that we'll use a lot when we're doing scientific notation.
Okay, but I don't understand how they're equal. That's what I'm saying.
So yeah, then 1 to the negative second power, 1 times 10 to the negative second power.
See, why are you putting the 1 there if we're just doing tens?
Because that is.
Yeah, it helps it. That's what I'm saying.
Yeah, that's
That makes no sense.
okay.
If the original problem was just 10 to 100, then why would you add the 1 if that wasn't part of the original problem? See, you're adding.
Yep, as an example, I'm adding that, yep.
Yeah.
So that equals, look at number 9, that equals y to the negative 7th power. I'm giving you these, so you may want to pay attention. S to the negative 5th, if we put that in the denominator, that's 7 over s to the 5th. And then t to the 3rd in the denominator, that makes it positive. We could make this 3 to the 18 minus 3, which is 3 to the 15. This equals 1. this equals z to the 7 minus 34. Yep, so z to the negative 27. How would we write that as positive 27? You take this and put it in the denominator. So it would be 1 over z to the 27.
What does number 10 say?
And then 4 to the third. So, sorry, 4e to the third. And then we'll move the f to the negative second to the bottom line to make it positive. Okay. Does that make sense?
Yeah.
You starting to see the pattern?
Every time it's
Allison?
number 8. 1 over.
Yes, then we make this positive
Yeah, Jake. I'm thinking.
by writing it in the denominator. 1 over e to the third. Yep. Yeah, so do 1 through 20. Whoa, sit down, guys. Sit down. You need. Okay. And then let's do 7 through. Let's see.
18.
No.
Whoa, that's.
So like 7 through 8.
Yeah, we'll do some more of this tomorrow. Just do 1 through 20.
Okay. On this.
Yeah.
That's it?
That's